There we go. Sweet. Okay. So without further ado, let me get the presentation going here. Share screen. Okay. Oh no, is it going to make me have to restart Zoom to do this? I hope not. Yeah, it is. Crap, I should have set this up for folks. I'll be right back.
So you guys are going to get a little break from JavaScript. I mean, you're going to have to use JavaScript to work with APIs, but it's not going to be a whole bunch of new stuff. It's funny to watch some of your reactions in the chat whenever instructors ask about JavaScript. I remember in my cohort there was a JavaScript riot in the chat. People are like, "Boo, down with JavaScript." But I loved it. I loved it.
So I had a question for you. So doing the boot camp, does it count towards being self-taught, or is it like no, like being in the boot camp?
Does it count towards what?
Being a self-taught developer, like what Ryan was saying.
I mean, you got to do a lot of self-teaching to get through the boot camp. So I'd say yes.
Great, great. So I can call myself that.
Yeah, I mean, a lot of self-taught is asking people how to do things, and then practicing it on your own. But yeah, you got to learn it from somewhere.
A lot of practice.
There we go. That was way harder than it should have been. Okay, you all can see my screen, right? Okay, excellent. I did want to mention one more thing before I get started, just sort of going back to my previous comments about a little bit about me. So I lived in Syracuse full-time for a very long time and still back there periodically, but these days I'm actually in Philadelphia. So still kind of proximate, but not in Syracuse. So I'm not there day to day. So we're not going to have any of our stuff in person because of that. I am going to try my best to make it to the July Open Hack. I'm up periodically, but so I just wanted to call that out, like in case you're wondering or curious what's going on there. Yeah. Cool. Okay. So we this week and next week are going to be talking about networking and APIs. So ahead of time, I put out some material that I think Max was able to distribute, some reading that I asked if you could do. If you can't do it, it's fine, but it's just sort of a high level overview of some of what we're going to talk about. So let's get into it here. Today is going to be quite theory heavy. We're going to start sort of going through some networking fundamentals, talking about how computers communicate on the internet and things like that. And then near the back half of the class, we're going to actually do some communication on the internet ourselves. So there's just sort of like a decent amount of headway we got to get through here, but I promise there's going to be some examples coming later in the day. Okay. So, oh, actually, one other thing too. Let me send this presentation somewhere where folks can find it. I think this channel works. Yes. Okay, cool. This presentation is for this week and next week. It's like everything merged into one big presentation. Just a bit easier for me to manage that way. Feel free to open up, follow it along. Some cases over these 2 weeks where we might have to copy some stuff from it. So it's good to have that link sort of around. And And that'll probably end up in whatever notes we have for this day as well. Okay. Cool. I see someone's in here, so it looks like people can access it, which is excellent. What is networking? So starting at sort of the base fundamentals. Networking, oh, can I put the link in the chat? Yes, good call. Networking is the process of connecting computers together. So the internet, there are a bunch of computers all over the world. And those computers are all connected together with wires. And data is flowing from one computer to another computer. And that's what the internet is behind the scenes. It's sort of this like amorphous thing, but when you break it down into its fundamental components, that's really what it is. And like, I wanted to come up with an analogy we could work through to sort of add all these attributes about how the internet works, and then to help sort of make it easier to understand. So what I came up with is an analogy of like the postal service or the post office. And what we're going to do is we're sort of going to work through this and adapt this analogy to sort of fit how the to make it map to the internet. We're going to sort of use that as an excuse to talk about a lot of interesting parts about how the internet works along the way. So in this analogy, imagine that every house is a computer, and then all the roads that connect those houses together are the cables that connect computers together on the internet. And as you'd expect, like if you wanted to go from one computer to another computer or one house to another house, you could like come out of a house, go down its driveway, walk along the road, walk up and go back to the other house, and there we go. And now you've sort of made that connection. But like, how does this communication actually work? Like, there's got to be sort of some under the hood details there to make that happen. It's not like there's not a person walking on the internet. I mean, there's wires, not roads. So what is that? Well, computers communicate with this thing called TCP, Transmission Control Protocol. So TCP is the system that allows computers to connect to each other and send data from one computer to another computer. It's sort of the whole process by which that communication gets sent. So in the case of like the Postal Service, TCP is like the operation of sending a letter from one house to another house, sort of like setting up that connection, dropping it in the mailbox, having to go through the whole thing, and then end up at the other person's house. You'll sometimes hear me use the phrase TCP socket as well. That just means like a connection. So if two computers are talking to each other, they have between them what's called a TCP socket, like a pipe that sort of they can send data between. And that pipe's like exclusive to one computer on each end. So one computer can put data in one end, the other computer can pull data out the other end. It's like just a pipe between those two systems. Yeah, that's kind of what I just said. TCP is like the postal service system. It's the process that facilitates sending mail. Exactly. So if we want to send a letter from like 100 Oak Street to 103 Oak Street, what's going to happen there is you're going to get your little piece of mail, and you're going to get the little mail truck. You're going to put the little thing on the mail truck and have it bring it over there and drop it off at the right house. And there we go. So how does the Postal Service know where to send your letter? Or rather, how do computers know where to send your data? Same kind of idea. Like, I mean, if you think about it, like if you're sending a letter to somebody, you have to put something on that letter to say where it's going to go, an address. So in the real world, like addresses, on the internet, you have what are called IP addresses. Internet protocol addresses is what that stands for. This is a unique identifier for every networked computer. So every computer you're going to talk to has a different IP address. And if you attach an IP address to a bit of information you want to send on the internet, the system should make sure that data makes its way to the computer with that IP address. IP addresses that we're going to talk about in this module are formatted as 4 numbers that are all from 0 to 255. So not negative, like just in that 0 to 55 band. And it's like one of those numbers, period, one of those numbers, period, one of those numbers, period, one of those numbers. So 4 numbers separated by 3 periods. So x.x.x.x, like 192.168.1.24. This is an example of an IP address. And here's another example of an IP address. We could do a whole deep dive on how these work, but I'm going to keep it pretty opaque for now. Really, the important thing is that every computer has a unique one. So every computer we're going to talk to. And actually, one more thing I will mention, this is system of IP addresses is what's called IPv4. There's sort of a newer standard. We're not going to talk about that. The newer standard is called IPv6. It's more complicated. We're just going to talk about IPv4. It's still quite relevant these days. Okay, so let's update our model. So we're going to change our model. Instead of having street addresses, we're going to have IP addresses. And I also swapped out the images for computers too. So now every computer, instead of having that street address, has got that IP address. And now it matches how the internet works. Okay, cool. Next thing we're going to add, network interfaces. So network interfaces, or a network interface, is a mechanism that a computer can use to communicate with the internet. So what do I mean by that? Well, if you have a computer, maybe these days it's not as big of a thing, but if you think of like an old school, like desktop tower computer, it could maybe connect over Wi-Fi, and it maybe could also connect over like an Ethernet plug. Those are sort of two different ways it can communicate. It can connect out to the internet. Think of those like there are two different paths, or sort of two different directions that traffic can go. And usually these interfaces are broken down by technology. So like you have one interface that's for Wi-Fi, one that's for Ethernet, and then maybe like one that's for like, I don't know, cellular, like on a phone. That's actually a good example too. If you have a phone, you can connect to both cellular and Wi-Fi. And that phone has two network interfaces, one that goes through cellular, one that goes through Wi-Fi. You can send traffic through either path. And also, each interface has its own IP address. So a computer can have multiple IP addresses because the IP address is actually on the network interface and not the computer itself. I'm going to add this all to the diagram in a second, and it'll make some more sense, but I just wanted to get through this to start with here. So also, lastly, every network interface has a little identifier. And usually they are a few letters that are lowercase with a number at the end. And usually those letters are like based on the technology. So for example, ETH1 means Ethernet, like usually the second, because it's like 0 base, 0, 1, 2. So like the second address or the second interface. Or WLAN 0 is like the WLAN or Wi-Fi interface. So the way we're going to represent this in our model is if you have houses that have multiple driveways or computers with multiple network interfaces. So you can see here, if I flip between the slides, I have 192.168.1.100, 101, 102, 103. Okay, now go to the next slide. I've added my interfaces along the driveways, but I've also added another IP address. So notice this now has EN1, and that has its own IP address, 192.168.1.104. So importantly, if I send data to this IP address, it'll go to this computer. If I send data to this IP address, it'll go to this computer. So I can send data to either IP address and just picks which network interface it goes through. Cool. I should also say, typically the way I've done careers in code is if you have questions, just please interrupt me. I'm also gonna I'll periodically ask do you have any questions, but just feel free to interrupt me if something I'm saying isn't making sense. But with that being said, any questions so far before I keep moving? Okay, sweet.
I have a question.
Yeah.
So within just make sure I'm picking up what you're putting down. So within the TCP, you have network interfaces. Are there specific network interfaces that download only and some that upload only, or each network interface can do both?
For everything we're going to talk about in this module, each network interface can do both. I don't, off the top of my head, I don't know if there are unidirectional network interfaces like that. Wouldn't surprise me if such things existed, but that's something we're not going to talk about if such things do exist.
Okay, thank you.
Yep. Anybody else have any other questions? Okay, I'm going to keep moving then. Okay. So next we have a neat little exercise. First time we're going to do an exercise in this module here. We are going to have you list the network interfaces on your computer. So you can take a look and see like what network interfaces your computer is listening on and what IP addresses they have. Sort of show you kind of what's actually going on under the hood a bit. So the way we're going to do that, I'd love if you could follow along if you can with me, if you're in a place where you can do that. So I'm going to open up a terminal. So I'm going to type terminal and hit enter. Now, I don't know if you've used the terminal all that much. In the past, Max has said that you haven't too much. We're going to be using it a bit today. High level, like we're not going to get too far into it. It's largely just going to be like a follow the leader, copy and paste sort of thing. But it's something that we're going to use a decent amount in this this section. Okay. So we're going to type a command in the terminal, ifconfig, all one word, all lowercase. I also have it in the slide as well, and I'm going to hit enter. And when I hit enter, I'm going to get a bunch of text. And I can scroll up and down through that text and take a look at it and see what's in here. So in this text, at the very beginning here, these prefixes where it says like a few letters and then a number before a colon like that, those are network interfaces. So you can see, at least on my system, I actually have quite a few network interfaces. Many of them are sort of like kind of like duds. You can think of them sort of as like a garden path in like our metaphorical analogy with the mailboxes or the postal service, where like it's maybe not a very well used route, or it's like a very specific route used for like one or two things here and there. And then there are other ones. I'm trying to see if I can find, yeah, like yeah, here we go. So on my system, EN0, that's my main network interface. And this is sort of, I'm on Wi-Fi right now, and that's it. And this is sort of like the network interface, pretty much all my stuff's going through, like the Zoom calls going through that. Oh, excuse me. I need to close my window. This is going to be bad. 1 second, sorry. Didn't realize that was still open. Background noise just kind of gets blends into the background. Okay.
Can you show me?
So
Can
yeah.
you show me what you typed in again to get this?
Yes. So I typed ifconfig right here. I'll do it one more time in the terminal. ifconfig. Cool. So as I was saying before, the EN0 network interface on my system is sort of my main interface. It's where all my traffic's going through, the Zoom calls going through it. Any like web browsing I'm doing is going through it. I'm just on Wi-Fi and that's it right now. So generally, could I get some thumbs up reactions from folks in Zoom if you've been able to have success with this? Just want to make sure people are following along. Cool. I'm seeing a decent amount of thumbs up. So I'm gonna keep moving forward. If you're having problems though, feel free to interrupt me. Okay. So that's the network interface name. The other thing to look for is the IP address. So we talked about how every network interface has an IP address. The one I'm going to look at is EN0. And it's probably on your system going to be EN02 since we're all on Macs. I should say like on Linux, it tends to be, or many other Unix systems, it tends to be like interface is discriminated by like technology, like WLAN0, ETH0, ETH1, that kind of thing. On Macs, it tends to be that most of your network interfaces are just EN0, EN1, EN2, so on and so forth. Kind of just like not really discriminated by technology, just like a list of them all. So most likely you want EN0. So I would say, look, scroll through that list, see if you can find a line that starts with EN0 at the beginning. And once you've done that, you're going to want to look at this section here. So sort of you can kind of see how like it's indented this area here. And if you're having like trouble, if it's like wrapping weirdly and stuff, you might want to make your terminal a bit wider. That can often help. But in here, under this, you're going to be looking for a line that starts with INET. And the number right after the series numbers with the dots in between, that is your IP for your computer. So for me, it's 10, 100, 10, 18. For you, it's almost certainly going to be something different. So if you can, I'd like you all to try to find your IP address. So look for EN0, look under the section underneath, look for INET, and then look for the thing after it, the 4 numbers with the dots in between. If you found that, give me a thumbs up in Slack or a reaction just so I can make sure folks are following along. And if you're not, let me know and figure it out. Cool. So if I had to guess, for the majority of you, your IP addresses are going to start with like 192.168 or like 10 dot or something like that. So if that's maybe a clue to help you try to find it, but okay, cool. Also, someone mentioned in the chat their IP. So in this case, it's not really that sensitive of information. Like, it's not really much we can do with it here. The reason why, if you're wondering why I said your IP probably starts with 192.168 or like 10 dot or something, is we're not going to talk about it, but I'll just briefly touch on it, that like there are ways by which you can sort of hide and like cap off all your internet traffic so that like you can protect yourself from the broader internet. There's this term called a firewall, maybe you've heard thrown around, and almost certainly you all are behind a firewall if you don't even know you are. So this IP address is most likely not something people can just make requests to from the outside. So it's not really that sensitive of information. But yeah, anyway. NordVPN. Wonderful. Though I will say actually on that VPN topic real quick, that the way a lot of VPNs actually work behind the scenes is they will make a network interface and they'll send all the traffic through that network interface. And then the VPN provider will write software that sits on the other end of that network interface, like locally on the computer, and will like sort of read the data and then like encrypt it and send it over to the VPN. So that's actually how that works often behind the scenes, if you're curious. Okay, but back to our regularly scheduled topics here. There's a lot more in this, and we could do a whole deep dive into what a lot of these things mean. We're not going to. We're sort of doing a high-speed overview of a lot of things today. But if folks are curious and want to ask me offline, be more than willing to try to get into it some more. Okay. Oh yeah, we just did this. I just had you find your IP. I'm getting ahead of myself. Makes sense. Cool. Any questions? Sweet. Okay. So there are 2 network interfaces I want to call out. EN0, which I already mentioned. On Mac, this tends to be your Wi-Fi interface. The other one, LO0. That one's almost certainly at the very top. LO0. So you'll see this one also has an IP address. Its IP address, though, is 127.0.0.1. And if everyone looks for this one, almost certainly the first one in your list, you're all going to see the same IP address. It's going to be the same for everybody. And didn't I just talk about how everyone has like their own unique IP address? Like, how would that work? What's the deal there? Well, we now get to talk about the local loopback interface, which is a special little interface that lets us do some very neat things. So this is a network interface, a certain kind of network interface that every computer has. And what this network interface allows a computer to do is to make a request to itself. So think about this like a little driveway coming off of the house/computer that just like goes right back into itself. And importantly, doesn't go to the road. It's only sort of local to that computer. So what that means is like this computer here can't make a request to this computer on its LO0 interface. The only way this computer can get into this computer is over EN0. So why is LO0 interesting, this local loopback interface? What does it let us do? I think Max has used the live development server thing in VS Code with you all, right? Does that ring a bell? I'm hoping it has. It does. The way that works is your computer hosts a little web server on it, and then your web browser then makes a request to the computer itself to show it. So this is often a thing that's pretty helpful, where sometimes you want to like see the status of what's currently running on your system, or you want to make a request to something that's running currently on your system, or maybe you want to trying to think of another good example. Those are the only two that are coming to me. Yeah, so in general, it's quite helpful, and it's a way that you can make a request to yourself. Okay. Any questions? I'm gonna keep moving forward here if not. Okay. Oh, yes.
Is the browser's local storage an example of LO0?
No, not exactly. So that's built into the web browser itself. So if you're doing things with local storage, that's not making it a request over the network. That's sort of just storing things locally in the web browser.
Gotcha.
Yep.
Thank you.
Yep. Okay. Next thing we're going to talk about, and by the way, if the local loopback thing is a little bit confusing, we're going to be using it quite a bit later today, because we're going to be doing some tests to make requests. Like we're going to do things where we like talk to ourselves and things like that. It's going to be cool. So we're going to use it a bit more. I think it'll probably make more sense later today. I gotta say, just like total side note, the fact that Zoom has threads in like the meeting chat now is blowing up my mind. Like this didn't used to be a thing. Anyway, okay. DNS, this is the next thing we're going to talk about. So continuing with sort of blowing through it at high speed, a lot of how the internet works. DNS is a way that we can assign human readable names to IP addresses. So what you can think about this is like a table. This table is sort of on the internet. It's sort of globally available. And a table has like the name of like a person or whoever is running that computer or living at that house. And then the IP address, the address of that house. And the idea here is the power of DNS is it means that when one makes a request, they can make a request to just say like, I want to make a request to John Doe. And then if this table is globally accessible, then the system can say, oh, what's John Doe's IP address? Oh, that's where John Doe lives. Okay, I'm going to send it there. Having to memorize IP addresses, like, oh, I want to make a request to 192.168.1.59. I mean, we can do it as humans, but it's just like, it's not really how our brains work. Like, it's much easier for humans to be able to attack names of these IP addresses. So that's why DNS exists. It's really a system to make things easier for humans, less so for computers. And it's a system that anytime you go to any website, like something like google.com, that google.com behind the scenes in a big DNS table maps to an IP address. And that's how your computer knows where to go to. So if you didn't have DNS, you'd have to type in IP addresses into your web browser every time you wanted to go anywhere. So the other DNS thing I want to mention is there's a DNS record that exists on pretty much every mapping the string localhost to 127.0.1. So what is, if you make a request in a web browser, way we're going to do in this section to localhost, what that will do is that will make a request through that LO0 interface back to yourself. So it'll do the DNS look, figure out it's 127.0.0.1, and then that'll cause it to go through LO0. So anytime you see localhost, what that means is you're making a request to yourself, usually for debugging or testing purposes. We're also going to be using DNS quite a bit later on in the section. So hopefully it should be, this is just an initial introduction here. But any other questions or any questions? Yes.
So until today, I used to like, if I needed to know my IP, I would just Google what is my IP address. It'll give me a string. For example, to use in Google Analytics to filter certain sessions from a source. But now I see like there's like multiple IP addresses, which have like the default ones are 192.168. But there's also like 4 characters, colon 4 characters.
Yeah.
Like, what's the difference?
Yeah.
And even my Google, even when I Googled, it's showing that longer IP address. So like,
yeah. So I'll go into this real quick here. I will say that you're starting to poke some holes in my analogy, and that's fine. I like that, but just understand that I'm trying to keep things simple just to sort of explain some of the high level concepts. But the quick answer to that is that alphanumeric colon separated syntax, that's IPv6. That's the new version of the IP protocol we're not going to be talking about in this section. In effect, what they do are the same thing. Like, you have an IP address, every computer has one. And the reason why IPv6 is better is it's much longer. So the reason why it got created is we started running out of IPv4 addresses. Like, there just weren't enough numbers to represent all the computers that are now connected between, like, now we have billions of people on the internet, but also like all these IoT devices and cell phones and all this stuff. So it just, we started exhausting the pool of IP addresses and needed a larger pool. So the alphanumeric thing, like, it gives you, like, besides just numbers, you've not got letters, so you've got more possibilities you can fit in that shorter, in that length. But your other comment around, like, I think it was partially about IPv6, but I think the other thing you might have been asking in there as well was, like, I'm looking up my IP, like I'm looking up on the internet, what is my IP? And the IP I'm getting back and the IP that I'm seeing in ifconfig are different. And that speaks, so like, even if you were to look up, like, what is my IPv4 address online and get the one with the numbers and the dots, it still would be different than what you see in ifconfig. And that is very purposeful. And the reason why that is the extra bit of complexity I'm not showing on my, like, neighborhood diagram is, in practice, most computers that are on the internet that are not sort of like servers or more enterprisey or data center grade stuff will actually be this, like, little, like, firewall thing. So you've maybe heard the term LAN, local area network, before. Maybe folks have, maybe they haven't. But in effect, you can think of it in that diagram, the neighborhood diagram, as like a bunch of cul-de-sacs. So it breaks down a little bit, and this is why I don't get into it, because it's like adds a bit of complexity that's kind of hard to hand wave around. But think about, like, there being a cul-de-sac that's like a bunch of driveways with a bunch of houses on it that goes into one house that's like a guardhouse or something. And then coming out of that guardhouse, connecting to the main road, is like another driveway. And that driveway connecting to the main road has a network interface. So it's got like EN0 or whatever. And what happens is, when you make a request to something on that cul-de-sac, you have to go through that guardhouse. So you go to it, that's a computer. It intercepts that traffic and, like, looks at it and makes sure it all looks good. And then if it looks good, it then sends it along to the proper house on the cul-de-sac. And there's a bunch of technologies in play to make that work. But the reason why you're not seeing the same IP is because if you think those are two different road networks. You've got the outside, like the main roads, like the roads that like the county or city maintains. Those are sort of like the full-on thing. Then you have this little private road network. And it turns out that you could configure it so that every house inside of that little like mini road network gets a public IP address. But that would actually exhaust the IP pool even further, and also means that then every house within that little cul-de-sac is publicly routable. So anyone, anywhere on the internet can send data to anyone in that cul-de-sac. And like, because most of these are like devices in someone's house, it's never going to receive an incoming like thing like that. It's not going through the guardhouse first. It just kind of doesn't really make sense. So like, there are some technologies at play. I'm not going to get into them too much because they frankly are like probably going to go over most use head at the point you're at right now. But there are technologies at play that effectively allow different an IP address for the like smaller road network, and then you'd have one like main IP address for the guard house. That because everything talking to the internal network, internal cul-de-sac network has to go through. From the outside world, anything it's making a request from the cul-de-sac looks like it's coming from the guardhouse. Did that make sense? That was just off the cuff, but
No, but thank you. Because a lot
okay,
of people
fair
don't
enough.
know it. It's like really new to me.
Yeah, no problem. If it's something you're still curious about, maybe if we've gotten a bit further along, you can rewatch the recording. But yeah,
Yeah,
cool.
but I did get a thank you.
Cool. Okay, so Rain.
Just quick question regarding the
Yeah.
IPv6 that you just mentioned. Are
Yeah.
those also referred to as the MAC address, or is the MAC address something similar or something separate that uses colons as well? And hold on, wait. And when they
Great.
say MAC address, are they
Yeah.
referring to Apple computers?
Great question. So the first one is IPv6 and MAC address is the same. No. So this is another one of those things where I'm hand waving over a lot of details. But the short answer is that the internet has a lot of different layers it works at. So like at the base level, you've got like electrical signals being sent through wires. And then there's like a small level of things that are built on top of that, like sort of systems and ways people can communicate to make that work. And there's sort of systems built on top of that, on top of that, on top of that. And it sort of gets to a point where once you get like 7 layers up, they call it the 7-layer model of networking. So 7 different interface layers between there. Once you get to that top level, you actually start to have something that's very abstract and easy to work with as an application developer. But the reason why I'm saying all this is MAC addresses are, I believe, a layer 2 thing, which is like much further down, much closer to the hardware. And it's a totally different, unrelated thing used for a similar kind of purpose, but like at a much more basic level. So probably more detailed than you asked for, but no, the same. And when you asked about MAC address being like Mac, like Apple Macs, no, it's also different as well. I am trying to remember what MAC address actually stands for. I'm going to quickly look it up here just because media access control address. That's not what I thought it was. Okay, not very helpful. But it's unrelated. Although I will say, since it sounds like you might be curious, every computer that connects to the internet does have a MAC address. It's sort of a lower level detail. So it's like Linux systems, Windows systems, Mac systems, Android systems, everything's got it. I don't know if that answered questions or gave you more questions.
It was more information than what I've already known. So thank you.
Cool. Yeah, I realize that there probably folks have a lot of questions for maybe past things you've heard, and I do definitely want to answer them. And if Max gave me like another few days, I'd love to do a deep dive on how a lot of this stuff works. But unfortunately, we've only got one day to go through all this, so I got to simplify it a bit. Cool. So DNS, going back to that. So I'm going to add DNS to our model here. So what I'm going to do is I'm going to add a little table to the corner. And I gave my domain names sort of like family, house, neighborhoody names, smith.com, jones.com, johnson.com. I don't know. So now what I've also done here is I've given each of my computers, in many cases, like those DNS names. So smith.com maps to 192.168.1.100. So I'm putting smith.com right there. So this network interface, this IP address is now smith.com. So if I make a request to smith.com, that for all intents and purposes means 192.168.1.100. So it'll come in here, go up through EN0, go into this computer. There we go. DNS is another one of those things that can also get a lot more complicated, but I think this level of understanding should serve you quite well for a long time. Just a big table of mappings of what, like, domain name. Oh, yeah, and I also added localhost in here as well. The companies just because the difference. Localhost, all my 127.0.0.1s everywhere, I add a little localhost next to it. Cool. Okay. Okay. Ports. So this is the last sort of big thing we're going to introduce here. Oh, yeah. Sorry, folks. My internet today has been quite bad. Oh, gosh. Let me see if I can quickly. Okay. I think it might have fixed itself. Do things seem maybe better? I'm trying to keep an eye on it. Okay. Let me share my screen here again. We'll see what happens. Okay. Yeah, I will do that. I will stop my video. Maybe give it less things to send over that low bandwidth connection. Okay. Cool. I'll give this a shot and we'll see how long it goes. During the break, I might try to mess with things and see if I can make it a bit better. Ports. So this is the last sort of new concept we're going to introduce here. So far, when we've talked about communication from one computer to another computer, all that communication has sort of happened over like a shared pipe or a shared road. But often it's important to be able to discriminate what kind of traffic you're sending. So this is where ports kind of come into play. Ports are a way where a sender of data, can identify who should be receiving that data on the other system. The way this is done is you can specify a port. This is a number from 0 to 65535. So it's positive, not decimal. It's not going to be negative. It's just in that range. And typically, ports are assigned based on the type of traffic you're sending. You can think of them also kind of like different communication channels. So like maybe if you, like in the old school TV situation where you're like watching TV on a TV channel, you go to that channel and you're always getting like that kind of, that specific TV content. Generally, ports under 1024 are ports that have already been pre-assigned for certain types of data content. And ports over 1024 are ones that can be used for like whatever you want. Really say, okay, we're going to communicate on port 4000 for this transmission. And the way I've sort of chosen to try to add ports into this is by saying that like maybe Bob lives at this house or computer, and Susie also lives at this house or this computer. And Bob is going to receive all letters or all packages or all mail addressed to Bob, and Susie's going to receive all letters or packages addressed to Susie. So sort of going end to end through this whole sort of thing, if you have data that you go to smith.com, it's addressed to Susie, and it's got a bunch of data in it, what should happen? So the sender sends that packet, and look, and when they do that, they say, oh, okay, I need to send it to smith.com. So smith.com is this IP address. So it sends that towards 192.168.1.100. This right here, the EN0 interface of this computer. So travels along the internet, it gets there, and it goes to EN0 of this computer because it has this IP address. The computer looks at the packet. It sees it's addressed to Susie. So Susie is who gets that mail, who reads that, or in the context of a computer, that's sort of the process or the what's running on the computer that's going to process that data. So like if you have a web server and it's running on port, let's say 80, and your letters, your packet has a port of 80, it's going to go to that process on the computer. If your packet has a port of 5000, it's either going to go to whatever's listening on port 5000, or if there's nothing listening on port 5000, it's just going to not go anywhere. It's just like, oh, there's nowhere for this to go. I guess that's it. That's very high level how the internet works. So that's about as deep as we're going to be able to get for this section here. Before I keep moving forward, any questions about ports? Ports tend to be the thing in this metaphor that is the least well transmitted. So I'd love to answer any questions I can. Yes. Also, wait, real quick, I just want to make sure, I want to make sure I'm pronouncing your name correctly. Palash?
Yep, you got it.
Wonderful.
So I didn't really like get what ports are in this visualization of postal service.
Mm-hmm. Okay. Yeah. So think about a port as the address on the letter. So in particular, like who it's going to. So if you have two people living in a house, Bob and Susie, and a letter is going to maybe a certain house, like the letter can go there, but it can be addressed to Bob, or it can be addressed to Susie. It can be addressed to either person. Ports allow you a way to discriminate who at the house or which process on the computer is receiving that type of data.
Okay, understood.
Okay. Tara.
Hi. So who determines the port? Like, are you saying that we can choose our own port to send to specific people? I guess I'm missing it.
Yeah.
A little bit.
Good question. So the way you pick a port, or the way that tends to get chosen, is one of two ways. Either there's one common port that is like used for a certain type of communication that people agree on ahead of time. For example, later this week, we're going to be talking about something called HTTP. It's a bit of a preview. And HTTP is a type of communication that happens on port 80. And it exclusively happens on port 80. So anytime you want to communicate with another system that's like listening for HTTP requests, you will send them to port 80. It's just sort of the standard of how it works. So that's one way that ports can be picked. There's just like one that's just globally known. The other way it can be picked is you can just like mutually agree with another person. You can say, I'm going to send you data. I'm going to send it to you on port 4000 or port like 9999 or whatever. And the other person will say, okay, cool. I will listen for that message on that port. That sort of metaphor is like a walkie-talkie almost, where like you've got two people, one person listening, one person sending, and they have to be listening to the same channel for that to work. But like typically the way that works is if you have one of these like old school walkie-talkies, you like talk with the person ahead of time and you prearrange like, I'm going to be on channel 3. Make sure you're on channel 3 too. So when you send things, I'll get them, and sort of the vice versa the other way. So it's kind of both. Like often more common protocols or more common systems for sending data, it'll be the former, but often you have to fall back to the latter in certain cases as well. Does that make sense?
So can multiple people use the same port? Is that like, so if I pick port 2000
Mhm.
and port 2000 is already being used for something else, then what happens?
Yeah, so there's sort of two ends to this. There's as a sender and as a listener, or as like a sender and receiver, I guess. So if you think about like the walkie-talkie example, if you have 3 people with walkie-talkies and all 3 are on the same channel, and you have one person who's listening and 2 people like talk, they can both talk and the other person can receive and can respond. But what won't work is if you have multiple people listening and you have 2 people listening and then one person sending. The one person sending won't know rather, I guess the 2 people listening, you won't know like who that message is supposed to be for. Is it for like person A or person B? So the way it tends to work is with ports, as many people can send to a port as you want, but you can only have one person listening on a port at a time on a particular system. So like if you have 2 computers, if people can listen on the same port because it's like 2 different IP addresses, 2 different network interfaces, like that's fine. But it's just on the same computer, you can only have one process listening on a port at the same time.
Okay.
Is there anything else I can help clarify there?
No, I'm all set, thanks.
Okay. Sequota.
So my question is similar lines to that. So you made a statement about like, so if nobody's there to receive the port, or if it's sent to the wrong place, is there like a kickback to say like nobody was able to receive it or something? Like, how do you know
Yeah,
it wasn't received?
yeah, good question. So something like that kind of exists. Yeah. We're actually going to, I can show you that in a second. We're going to start sending some things and actually do a little demo here, and I can go through that case. But what tends to happen is if you try to send to either like an IP address that doesn't exist or to a port that no one's listening on, the system's actually going to give you an error. Like as the sender, it's going to say like, I can't find anybody to send this to. And it's sort of up to you to how you want to handle that. In some cases, like you just want to handle that as like, oh, okay, no problem. I'll send something later or something. In some cases, that might be like a fatal error, like, oh no, this person's not there. That's really bad, or that's a problem for the thing I'm working on or the system I'm building. So to answer your question, yes, there is sort of a return to sender kind of functionality. It's more of it's not like a returning the message, it's more just informing you that the message couldn't be sent. Cool.
I have just a quick question, very quick.
Yeah.
So would the TCP be like the guard master of the ports? Like when you try to send something to a website and it says, you can't access this IP or something like that? Or is there another name for like the guard master? That's probably not the right term, but I think you're picking up what I'm putting down.
Yeah. I guess what would I don't know if I have a good specific name for that in particular. Let's see. It's more like what you're describing is more of like a condition, like it's a thing that can happen. The closest thing I would say was equivalent is like if you had to come up with a name for what you'd call like a letter not being delivered in the postal service. There's not really like a name specifically for like a person or process that's like managing that. It's more just the way the system works. It's like a behavior of how it works, where
So it's just an undeliverable kind of thing?
Yeah, yeah. It's
Okay.
just like an undeliverable message, or the technical term in computing on networking is what's called a packet. Probably should have mentioned that. A packet is the equivalent of like a letter or like a box.
Great, thank you.
Yeah. Also, quick check-in. Has the no video made my bandwidth issues less of a problem?
Yep, much better.
Okay, I'm going to keep with this for the rest of the class then, and I'll see if I can try to figure out what's going on for tomorrow. Thank you for bearing with me, folks. Okay. So, kinda, this is how the internet works, kinda. I already said it a few times here, but I made some simplifications. There's some things I left out. But I think the metaphor and sort of what I've put together here should give you enough that you'll be able to get far enough along to be able to make some progress, and then sort of further learning as you can assign a slot into that as you go. Okay. Now so we get to actually start to do some stuff. So I get to do a little bit less talking, and we get to actually do some like typing and activities and exercises, which often is very exciting. Okay, so we're going to be sending and receiving messages on the internet. So let me break down exactly what we're going to do sort of like behind the scenes. We're going to use a tool that can effectively send data and receive data on TCP via TCP. So we're going to use this tool, and it's called Netcat. And Netcat is a terminal-based tool. So it's a thing we're going to use the terminal for a bit more here. I said there's going to be a decent amount of that in this this section, and I'm going to kind of continue with that theme here. So this is what the exercise we're going to do. We're going to use Netcat in two different modes, what's called the client mode and the server mode. So think of the client as like the transmitter, as like the person sending or speaking into the walkie-talkie, and the server as the person listening on the other end of that walkie-talkie. So importantly, as I called out before, you could have multiple clients all talking to the same server, but you really can only have one server listening on a specific port. So you may have guessed this 5678 number, that's going to be the port we're going to be listening on. So that's sort of, and this is we're kind of in that second category where we're just like prearranging a port we're listening on. There's no sort of standardized port we're using. We're just going to send some arbitrary text. It doesn't really fit into a standardized protocol that already exists. Okay, so I'm going to go through this here. Let me go through it once, just end to end, and then I'd love if you all could try it on your end and give it a shot. So I'm going to create a new terminal window. And in this terminal window, I'm going to make another tab. You can also just make a secondary window, but I think it's easiest if I make a second tab, at least for me. So I'm going to go to Shell, New Tab, New Tab. So I've got now two terminal windows in tabs. They're two separate contexts. Okay. In the first one here, I'm going to type this first command. Or actually, the second command. Sorry. I'm going to type the server command to start with. So I'm going to type NC space -L. Importantly, this is a lowercase l and not a 1. Space 5678. And I'm going to hit enter. And what should happen is it should sort of like hang like this. See a little spinny thing in the terminal there? It should just sort of like be static. There should be no sort of output. Okay. So now what I've done effectively after I've run this command is I'm sort of listening to the walkie-talkie. And anything that I say to the walkie-talkie is going to show up here. So on the other end now, what I'm going to do is I'm going to start Netcat in the client mode. So that's this command here. So I'm going to type NC 127.0.0.1 and then the same port. 5678 and hit enter. Okay, so now I'm in a mode where I can speak. I'm like in the speaking mode. So behind the scenes, what's going on here is I've sort of like started a server, And then on the other terminal, I've now connected to that server. So now after running this command, I've got a socket between those two connections, or between those two, these two processes. So if I type something into here, like hello, and then I hit enter, importantly, you have to hit enter for it to send. It'll show up over here. And then if I type in something back over here and hit enter, it'll show up over here. So now what I have is I've got this TCP socket that I can use for bidirectional communication between these two different systems. One last thing to call out here real quick. 127.0.0.1. If you remember that from before, that's our local loopback interface. This is a case where we're talking to ourselves. I'm making a connection to my local system, to this process over here running on 5678. So here's an example of where that might come in handy. Cool. So that's what I'd like if folks could do to give that a shot. I noticed someone in chat mentioned they were getting permission denied, and it looks like they might have deleted their message. If that's still a problem, let me know. But if not, that's okay. Fixed it. Cool. Good, because I wasn't actually sure what was going on there. We're going to have to work through it. So excellent. Okay.
Ryan, which one is the client and which one is the server?
Good question. So the client is this one. My screen isn't that big. I normally do this on a bit of a bigger screen, but I'm a bit limited today. The client is this one. The server is this one. On this, how do we tell the client which is which? Good question. Unfortunately, Netcat will tell you. Often, though, in many other tools, it'll give you some more information. It'll say like X was received or X was sent. So what that means is if you, on one end, you should say like, it should say X was sent, and on the other end, it should say X was received. So you should have corresponding messages in both things. Oh, you're just talking about like in general, looking at my terminal. Okay, maybe I misunderstood you there. I want to make sure I pronounce your name right. Goggin?
Yes, that's perfectly fine.
Wonderful.
So I was wondering, is there a way that I can use Netcat and like connect with some other person and chat like via this or no?
Yeah, great question, or great idea rather. Let me tell you a quick 10-second story. So the first time we did Careers in Code, it was fully in person. And I actually did this where folks could like communicate with each other. They could connect to each other's laptops. They were all in the same room. And it was amazing. And it was really cool. But now that it's remote, everyone's in differently interesting network environments that make it challenging to be able to do that. But this exercise originally was that, where you could talk with your fellow classmates. But I had to sort of downgrade it to just be talk with yourself, unfortunately. So great idea. I wish I could do it, but it's a little infeasible given the remote nature of things.
That'd be cool.
Quota, it looks like you're having some issues. Do you want to share your screen and maybe take a look? But my thought here is if you're having problems, and we can fix them, probably some other folks are having the same problems. Oh, Sequoia.
And you see my terminal?
Oh, maybe I have to stop sharing my screen first. Oh, yeah, that's what's going on. Yeah. Okay, cool.
So
Yep,
is this where I'm supposed to be?
Yep, that's where you're supposed to be. So, do you want to make two different tabs or two different windows? So you need two terminals to be able to do this exercise, one to put each command into.
So when I put it, it said, and I exit out of it, but it said like, it wouldn't let me do, like, do I need to get rid of like this in order to do it? Because like when I tried to like go to another.
I'm only seeing one terminal window right now, and I don't see anything that you've entered into it. Oh, wait. I think it's just, oh, okay. It just took a second to update. Can you go to your other tab?
You see both of them?
Yep, I see both of them now.
So I made a mistake and deleted it, but when I put in the NC 127, it said like it was an error or something.
Okay.
Then let me do that over and then I'll share my screen and show you.
Yeah. I mean, we can do it together right here and work through it if that'd be easier.
Okay, that's fine.
Okay. So are both your terminals empty right now?
Yes, hold on. Can I stop sharing for a second?
Yep.
I'm gonna share my desktop, my desktop, and then pull the terminal over so that you can see.
Nice. Okay.
Can you see it or?
I can.
So, I mean, I don't even have the. Can somebody read the thing to me again? It's
Yes.
like this, and then it's like NC.
NC space dash L space 5678.
And then press enter.
Yep, but one quick thing to note. So it looks like at the very beginning there, before you typed NC, you typed 0 tilde. Might have been by accident. If you can re-enter that, but just, yeah, you got it. So copy that, put that down below. Hit enter. There we go. Okay.
Oh, okay.
So now you got the server running. So now if you go to the other tab, you type NC space 127.0.0.1. .1. Yep, space 5678. So those ports, both of them have 5678. You're listening on the same channel. If you hit enter, cool. Now you should be able to send messages back and forth. So just give that a shot. Oh, you have to hit enter. Yep, perfect. There we go.
All right, thank you.
Yeah,
Okay, I also have a question about this.
yeah.
Sorry. Okay, so like, is this just, in order to be able to do this with somebody on another computer, they would just have to input, like whose IP address or like whose stuff are we using? Like, is this just a network channel that anybody can access from their laptop, or you can do this with?
Yeah, so good question. So the way that netcat command is structured, and we're going to talk about it in a second, break it down a bit more, but the netcat client command, it goes NC space, the IP to talk to, and then the port to talk on. So we're right now making a connection to 127.0.0.1, which is that local loopback interface, that localhost thing. So we're talking to ourselves, but there's no reason you couldn't put something else there too. Like if you had someone else's IP address, any IP address you can make a TCP connection to can go there.
I have a question.
Yeah.
So if we're communicating with someone via this method, how would it pop up on their screen? Would it be a web page that appears saying hello world, or?
Yeah, good question. So keep in mind, also I turned my video back on. I'm going to try to keep it on when I'm not screen sharing. I just don't want to be with that video. It's kind of, I like to talk with my hands. So if you send a message to somebody over TCP and they're not listening, nothing's going to happen. In fact, as the sender, you're going to get an error. It's going to say, no one's listening, error, you can't send this message. So if you want to, like, what's going to happen on the other person's end really depends on what process they're running to receive your message. In our case, for what we're doing now, we're running NC-L, the server side, we're running that to listen. That's our server. So that's what's going to like handle our messages. And what's going to happen is it's just going to print them out in the terminal. If you wanted to see what happens if like you didn't run the server, you could try to close your terminal and then do it again, but only run the client command. In fact, let me do that here and show you what happens. But what you're going to get is an error. So let me share my screen here. So if I go back over to my terminal here, I'm going to terminate everything. Yes, I've got my 2 terminals back here again. I'm just going to run the client. So I'm going to go nc 127.0.0.1 5678. So importantly, I'm not running the server. It's as if I'm talking into the walkie-talkie and no one's listening on the other end. I'm going to hit enter. It's just going to do nothing. Like it's just going to be like nothing happened. I can't connect. Importantly, though, if on the other end here, I start that server first, I begin listening, and now I connect. Now it's good. It's open. Everything's great. So that's what'll happen. If you don't have a server running, the connection just can't establish, and you aren't able to send messages. And if like, yeah, go ahead.
Oh no, I just was clearing my voice.
Oh, okay. I think I answered your question. Let me know if I didn't, though.
No, you answered it well. Just one thing, I just want to share my screen right quick.
Yep.
Hang on a second. All right, so I put this in here and I typed that, but on the other side, I don't show it coming back to me. Hold on 1 second.
Is the director of the Connecticut State Police Forensics Laboratory, and one of the world's most respected forensic experts.
I may be doing something wrong. I don't
Okay.
feel like
I have a guess. I know what happened here. So the order in which you enter these commands is really important.
okay.
You have to start the server before you start the client. So if you think about it, in the walkie-talkie analogy, I'm going to keep going back to that until someone says it doesn't work for them. But if you have somebody who talks into the walkie-talkie before the other person's listening, you can't, like, they're never not going to receive the message.
Okay.
So you have to start the server, which sort of is like the process that's like listening for incoming connections. You have to start that before you can start the client, which will actually make that incoming connection. You start them in the other order. It's like sending a signal before the other person's ready for it. So if you were to,
Sorry about that. There we go.
Okay, real quick, I will say, I was going to mention this in a second, but I'll mention it now just so we're going to do it now. If you want to terminate Netcat, the way you can do that is press Control C. So if you press Control C, not Command C, Control C in your terminal, that'll close Netcat. Okay, so now you got your prompt back and we can type it again.
Okay.
If you go back to your other terminal, your second tab, and then in here, type your Netcat. Oh wait, actually, oh no, I had that wrong. I thought you had them in the other direction. Okay, go back to the first one again.
All right.
Okay, type your NC-L5678 in here first. So you got to start NC space -L. Oh, I want to mention too.
And you know what? I did it up there. Oh, you know what happened? It was incorrect, and I just pressed the up arrow, and it corrected itself like prettier.
Ah,
Is that normal? Like, I don't know. Let's try it one more time.
so the up arrow, yeah. So the reason why the up arrow works there is, well, okay. Let's do a quick thing here. If you hit Control C,
Okay.
type test and then hit enter. Type like hello and then hit enter. And then hit the up arrow. What it does is it goes back to the previous command you typed.
Okay. All right.
So you can actually up arrow your way back to NC-. You can do it a few times in a row. So you can do up one more time and it'll go to test. So that's a neat little trick. And if you go down, it'll go back to the previous one. You can like alternate through them.
Awesome. That's great to know. Thank you.
Yeah. So go back to the NC-L5678 with all the spaces in it and hit enter on that. And then go back to the second tab you have open. And now hit up and enter on that.
Oh, okay. Awesome.
Okay, now you should be able to send messages back and forth. So importantly, we start the server before we started with the client. And yep, hit enter.
Nice. Thank you.
Yeah. Genevieve.
Can you show us how to connect with somebody else? Say, I don't know, if I had like Rain's IP address, how would I be able to say hi to her?
It's in the
Yeah.
chat, actually. I mean, it's they
I
can
know.
drop it.
Well, I gotta say first, I love your eye patch.
Thanks.
And so what's a little bit tricky here is I mentioned earlier, I sort of went into the metaphor around like cul-de-sac and some of the more complicated network stuff. The way that all of our networks are almost certainly configured, and in the case of Rain, the IP is configured in that way. You're not going to be able to communicate directly, unfortunately. And it's one of those things where there are security things in place that you have to sort of purposefully work around to make that happen, that certain systems will do. But it's just at the level we're at right now, we don't sort of have the tools and knowledge to be able to do that, or for me to be able to explain that to you in a way that could work universally across everybody on the call, if that could make sense. So that's a long way of saying, I think it'd be really cool to have us talk with each other, but to be able to make that technically happen is a challenge in the distributed environment. So it's not something you can do, unfortunately.
Ryan, if you're all on the same Wi-Fi, is it more straightforward?
Yes, but even then, you all have to be on a Wi-Fi network that's not locked down. Some Wi-Fi networks will actually, like at the gateway level, block messages between devices for like security reasons. The Tech Garden, for example, does that. Ask me how I found that out.
Why don't we just bring back AOL chat?
So it's because we're on private IP addresses that we can't.
Exactly. Yeah. So if you had two computers that were had public IP addresses that were not behind firewalls, that were sort of publicly available on the internet, you could do this netcat thing between those two computers. You could, on one computer, run nc-l 5678 or pick whatever port you want, doesn't really matter. And then on the other computer, you could do nc space the IP address that you want to connect to, the IP address of the other person's computer, and their port 5678, and that would work. Totally great. It would work as you would expect here. The only challenge is the IP you're connecting to has to be what's called routable. Has to be something that if you send a letter to that address, the letter will make it. And unfortunately, the way that all of our IPs are set up right now, they are not routable outside of our local areas, or most likely like our houses or the buildings we're in. And it's done for security reasons. So I know it's kind of a bummer. I really would like to be able to do this more broadly, but it's just kind of the situation we're in, it being distributed. I will say though, if any folks are in person in the same place and want to give it a shot, if you're on the same Wi-Fi network, both your IP addresses sort of probably going to start with the same numbers as well, which is like a nice thing to keep an eye on. You can give it a shot. It might work. It might not too, but it might work. The reason why I'm being a little bit coy about it is there's some security things in play that make it a bit hard to predict, and like, yeah, it's just it's an unfortunate thing that it's not easier for like a demo like this. Ozma, I think I just answered your question. I didn't see it, but I think I did. Okay, if I didn't, let me know. Sweet. Okay. Let me go back to sharing my screen here, and we will continue. I want to get through the next little bit of this before we take our break, just because we got a nice stopping point in like 10 slides or so. Okay, so I talked a little bit about it already. I'm going to kind of do it again. I'm going to break down what these commands actually do. And to talk about this, we're going to have to get a little bit more into how terminals work and how terminal commands are typically written. So typically, the way a terminal command works, and you've probably noticed this from the little bit you have used the terminal, like with running node or something like that, they tend to start with a word. And that word usually is like the program you want to run. So in this case, NC, netcat, that's the program we're running. In the case of node, you're starting it with like node space. Node is the command you're running. After that command you're running, you can pass any number of words that you want to specify as parameters to the command. And these sort of change how the command runs. So it's to sort of force it to do certain things or run in certain modes. And there are two general ways you format these parameters. The first one is what's called flags, and the second one are what are called positional parameters. So we're going to start with positional parameters. These are the easiest to understand. Just a series of words. Think of these like arguments to a function. So you've just got like argument 1 is this, argument 2 is the next thing, argument 3 is the third thing, so on and so forth. They're just space separated. So you look at name of your command, space, then like the first are positional parameter, space, the second positional parameter, so on and so forth. And because they're in order, like 1, 2, 3, like in sequence, the order of them is important. So if you did like NC 5678 127001, like flip the order of those, it would think like netcat would think the first thing you typed, the 5678 was the IP address, and it would think 127001 is the port. Like the way it's determining those is by the position of them in the command. The second kind are what are called flags. These are a little bit different, but are primarily do the same kind of thing. They allow you to specify parameters to a program in the terminal. The way flags work, though, is they are formatted in a different way. So positional parameters are indexed. So like the first one is the first one, the second one's the second one, the third one, the third ones, and the order is really important. With flags, you're more doing it instead of buying like an order, you're giving each one a name. So the way you structure this is you do dash, usually a single dash and then a letter. And that letter is like the name of it. So in this case, the name for this parameter is L. A little unfortunate in this font, L and lower and 1 look kind of similar, but this is an L and not a 1. That is the name of the flag. After the name of the flag, you put a space, then you put the value of the flag. So when netcat parses this, or like processes this input, it sees -L, and it says, oh, okay, the next thing after this must be whatever -L is. 5678, okay, then now that's the value of -L. So -L stands for listen. Listen on port, whatever. It's kind of the English sentence that kind of tries to break down to there. And what this means is when you specify this -L flag to netcat, it puts into a mode where it listens on the given port you specify instead of connecting to an IP in a port. So those are sort of the two ways you pass input to netcat. And just generally, these two patterns of positional arguments and flags, we're going to run into a few more times in this section. And also, you're going to run into throughout the rest of careers in code and just your career as a developer. Like they're very common patterns for command line tools. Yeah, here we go. So here's like another example of flags. So Pulash says the server takes flags and the client takes parameters. Correct. So in this case, the client takes two positional parameters, the IP and the port to connect to, and the server takes a single flag, -L, which is the port to listen on. So flags can also be structured a little bit differently too. You can also give them 2 dashes with like a longer name. So if you want to give your flag something a bit more, a bit like easier to understand, this is another option. But like you can put as many flags as you want in a row. Like so, fake program, whatever. I just needed something here. -A1, -B2, -- hello world. So this is giving us 3 flags all in a row that all sort of specify different kinds of input in this sort of like contrived case. The order of these though isn't important. Like this here should do the same thing as this. Like flipping the order of those flags, importantly flipping the order of the pairs. So like not just flipping A and B, like flipping like A1 was here, I moved A1 there. Like they sort of go together. So changing the order of those two does the same thing. The order is not important with flags. I'm going to flip that back here. And lastly, you can actually use them together as well. So this one is a little more complex to parse. I tried to break it down with colors to make it a bit easier. But it tends to be when you're looking at these command line lines like this. If you see like a dash something, the thing immediately after that is what's associated with the flag. And if you see things that are like before it, or like if I had something where like this was like this, like positional here, like dash A is for one, but then after that, like it's no longer the flag. It's now just like any series of positional arguments. Because this is kind of can be very confusing when written like this, usually they're written with all the positional arguments either at the beginning or at the end, but it doesn't have to be that way. But that's usually a good rule of thumb to do it that way. But there are a few commands we're going to talk about later that use this sort of format. Just want to bring it up. At least for netcat, though, netcat just has a version that takes positional parameters and a version that takes a flag, and that's it. So this is important for later, but not critically important now. Okay, and one last thing here as well to talk about. Shay.
You probably went over this, and I probably missed out, but is there any difference with the -A and a double dash hello? Like, is there any specific reason why A only has one dash and hello has two?
Yeah, good question. So the short answer is yes. It tends to be that if you have a flag that you want to be multiple letters, you put 2 dashes in front. As for why that is, I don't know why, it's just sort of how it works. So if I had dash A and I wanted to make this like dash, I wanted to turn it from like A to like ABC, most of the time you wouldn't do this, you would do that or that. So it's just sort of like the way you write it. The reason why I'm being a little bit coy about this is because there are some applications that do it this way, but for the most part, it's like this. And for everything we're going to be talking about in this section, it's going to be like this. Does that make sense?
Yeah, so basically if it has more than one letter, always use a double dash.
Yep.
Okay. Appreciate
And
it.
Is that convention, or is that like it won't work depending on what program it is? It's required to have 2 dashes or 1 dash.
So this is one of those things where it really depends on the program. Some programs it'll be important for it to have 2. Sometimes, like some programs, this will work. The reason why, just to peel back the covers a bit, is because the way this is implemented, there's a tool like a library or like a piece of code that can be used inside of other programs that takes all this data. And what this program will do is it'll like take all of its data that it received as a command line argument, and it will give it to that program and we'll say, parse this and figure out what flags are there and what positional arguments are there. And that like tool, that function will like give back all of the positional arguments, all the flags, all parsed for the program ready to go. And unfortunately, there's not just one of those. There's like many versions of those programs, and they all do things subtly differently. Those like flag parsing programs. For the most part, though, this format is the one that's been like agreed upon as like the right way to do it. But there are some variations. Like some people will do it like with the equal in between. Some people, as I mentioned before, do it like this. Some actually let you do weird things where if you have a single dash, you can like stack parameters together. So if you have like, let's say A, B, and C, and you want to make them like all one, you can do it like this. It's like kind of goofy, but that's like way more detail than we really need to get into right now. There are different variations, but this is the variation that is the one that we're going to encounter in this class. And also, Doug, I love that you're asking questions too. I'm all about it.
When they occurred to me, I was like, someone else might have the question. Just trying not to interrupt anyone else. Thank you.
For sure. Okay, so I also want to talk about the prompt. So the prompt is a thing that you've probably noticed if you've done some things in the terminal. It's this little bit at the beginning. For me, it looks like theta tilde or whatever. And it's because I've done some customization to make it a little bit different. But for you, it probably has something like, it maybe has your name in it, like your username in it. It's probably got like the name of your computer in it or something like that. And it's probably a little bit longer than this. But the prompt is what shows up when you open a new terminal window. So open up a new window, immediately you're going to see your prompt. And what the prompt indicates is that your terminal is in a mode where you can give it a command. So at this point, I could type in like nc-l, I could type in like node, whatever. There's a lot of things I could type in here, but like this means that I can do that. Let me show you an example where the terminal's not in a mode where I can type something. So if I run like nc-l5678, hit enter. After I've done this, you see I go to a new line and my prompt isn't there. I just like have an empty thing, like there's nothing in front of it. That is because this program is running. So if I now try to type, let's say I wanted to like run nc-l5678 again. I type like nc-l5678 and hit enter. That's not going to run that command again. In fact, what I've just done is I've sent this data to this program, and it's actually sent it through like an internet pipe or whatever, if I configured it in that way. But I'm bringing this up because something that I've noticed in the past students have really struggled with is when they get into this situation where they have a prompt and they'll type a command and they'll hit enter, and maybe it won't work, or it'll do something they don't expect. And they'll try to type the command a few more times. They'll be like, okay, and it won't work for them. And they're like, what's going on? And the reason why it's not working is because you don't have your prompt. If you try to type a command where you don't have your prompt, it's not going to work. So the way you get your prompt back when you're in this mode, I mentioned it briefly before, but if you hit Control-C, anywhere you are, it'll bring you back to your prompt, like an empty version of your prompt. So that means like you're in a program, you want to quit out of it, you type Control-C. Another thing too is if like you have stuff in your prompt and you want to clear your prompt, you can hit Control-C to clear your prompt too. So it's just like hit that to get back to a clear prompt. Universally, it should do that for you. So just a tip. I think it's going to help you folks out as we go a little bit further in here. But does that make sense?
Does it clear us out of what we were doing, or does it just bring us back to the prompt?
It
Like-
clears you. Yeah, go ahead.
Yeah, like the you know how we got the whole NCL5678, does it like delete that whole thing? So now I wouldn't have communication between the two windows anymore?
Correct. So
Oh.
Control-C will terminate the program that's running in the terminal. Think of it like the equivalent of pressing the X in the corner of a window. Okay. I'm going to keep moving forward. Cool. We did some stuff in the terminal. We did a little example. I think generally folks had success. At least I saw some folks had success. If you're having problems with it or want to reach out to me, let me know. I've got one-on-ones available, or we can find some time maybe later today during one of the exercises. So the last little thing we're going to leave off on here before we go to our break. So we're going to introduce sort of the next level here, which is cool. We've been able to talk with ourselves. But in practice, usually the way this works is you've got a computer on one end. Like talking with yourself is great and all, but the whole idea of APIs, we're going to talk about later, is that you need to have a computer on the other end that can read what you're asking and give you back answers. In order to do that, we need to have a format that messages can be sent in. So think about this. Imagine you have two people, one person talking to the other person with Netcat, and one person types English, and the other person can only understand French. That's not going to be a very good conversation. Like, you're not really going to be able to understand what the other person's saying. People are going to be lost. It's probably just like people are going to get confused. You might get a little bit here and there by kind of deciphering roughly what's going on, but you're not going to be able to really understand what the message in its entirety. So similarly, we have a problem similar to that with a computer. Like if you send a computer just like English text, it's really not going to be able to understand deeply what's going on. And that's where protocols come into play. So a protocol, you can think of it like a specification for the way you should format data. And if you send data in a specific format, then the server, that's a machine, can understand what you've asked it. And also importantly, if the server sends you back data, like maybe you ask it a question and it gives you back a response, it can send you back that data in a way that you expect to receive it in a way you can understand what you've gotten back. So this common language is like really key to being able to allow systems to communicate effectively on the internet. So what we are going to do after the break is we are going to do the same thing we just did with Netcat, but instead of talking to ourselves, we're going to talk to a server out on the internet somewhere, a server that I've written ahead of time. And this server understands a protocol that I've sort of devised. Now, I should be clear, this is kind of a contrived protocol. This isn't a real thing. I made it up. But it should sort of give the high-level overview that you need in order to understand what's going on, and give you the gist of what it's like to communicate with a server, a machine on the other end. So this protocol allows you to ask questions to the server. And when you ask it a question, the server can respond with a response. So there are 3 different formats the questions can be in. And the way that they structure those formats is it's sort of like a 2-word protocol. So the first word, the space, and the second word. The first word is a question identifier. So that's like, there are 3 of those, FAV, MAN, and IST. And each of those sort of is like a prompt. What is your favorite blank? How many blanks do you have? What blank is it? And then the second thing you pass to it, the word, that goes in the blank. So if I like sent the server FAV programming language, the server would then understand that to be the question I ask is, what is your favorite programming language? If I were to change like FAV for like IST, I'd be asking like, what programming language is it? Which I guess doesn't really make sense, but I think you get the idea. As a response back from the server, there are, I guess, actually 2, but I only listed out 1 potential response here, ANS. So that sort of decodes into the answer is blank. So similarly, you'd get like, maybe you ask the server FAV programming language and you get back ANS JavaScript. I didn't enumerate it here, but it's probably not going to come up, but there's also an ERR response. So like if for some reason the server can't respond, it'll be like give you an error. It'll be like ERR, I can't respond to that question. So that's the protocol I've designed. It's relatively simple, relatively straightforward, hopefully. Yes, so I wrote a server that we can communicate with this. And I think take our break now-ish, and then when we get back, we will send our first messages to a system outside of our local network, to a server out there on the internet somewhere that can actually like do something with our data, which is exciting. Cool. How's everybody doing with all this? Is it sitting well? I'm seeing some thumbs up. Excellent. Cool. Okay. Oh, move pin. Okay, so I think I think we're gonna take our break. I need to remember exactly. Oh, actually, we're a little bit later than for some reason I thought the breaks were at 7:30, but they're normally at 7. Okay, well now I know for next time. So let's do maybe from now until like 7:45. Does that sound good? Okay, cool. So I will see you back here then. Have a good break. Excellent. Hopefully everyone had a good break. So we are going to utilize a protocol, sort of going back to what we talked about kind of before the break. I wrote a protocol. And also, yes, I see a bunch of you are still eating, totally fine, no problem. But I wrote a protocol, sort of this contrived protocol we're going to use to talk to the server online. And I wrote a server that understands that protocol. So this is the first time we're actually going to connect to a server running out on the broader internet on a real DNS name, on a real port, like escaping our little local loopback safety zone in our little like computer house thing in the diagram. We're gonna like go out on the real driveway, the real roads, take the internet for a real test drive here. So I am going to give you a little demo of what it's like to ask my server a question. And I'd like everyone to replicate it sort of after I do it, to go through sort of the same kind of motions to make sure everyone's sort of got a handle on how it works. Okay. Yeah, I'm just gonna do this here. So the way we're going to do this is we're going to utilize that netcat command format. That's the client version. So thinking back to what we did before, we started a server locally, and then we started a client, and then now we could communicate. But the server had to be started first. So you can think of that I've already started the server in the internet somewhere. So like it's already started out there, and we're connecting to the already started server. So I'm going to open up my terminal again here. And I'm going to type nc careersincode.xyz. So this is where the server is located. This is the domain name I've given it, the DNS record in that big table. And then the port we're going to communicate on is just an arbitrary port I've picked for this protocol, 4000. So importantly, it's above 1024, so it's not a pre-reserved port. We can communicate whatever we want on this port. It's something that's just available for use by anybody. Okay. And when I hit enter, I'm now going to get my little empty thing here. Importantly, though, notice I don't have my prompt. So I'm connected. Things are good. I'm connected to the server. It hasn't like kicked me back to my prompt again. The netcat command is running. So now that I'm running, it's running. I can type my request. I can type in the question I want to send to the server. So we're going to go sort of go through this in a second. I'm just going to type FAV Apple. What's really important here, though, is I'm sending something to the server. I'm hitting enter, and notice it sends me back a response. It sent me back ANS Macintosh, and there we go. I just sent a message to a server out on the internet somewhere, gave me back a response. And then I can hit Control-C, and I'm done. So we're going to do a bunch of these sorts of exercises here. So for each of these exercises, we're going to send some data to a server. We're going to go through the same kind of process I just did, but just a bunch of different questions. They're going to use the protocol that I outlined before. And again, the server is on careersincode.xyz on port 4000. So those are sort of the 2 bits of information, careersincode.xyz, port 4000. Okay. So the first question we're going to ask is, what time is it? We're going to do this one together. And the rest of them I'm going to let you mostly do on your own, assuming this one goes well. So what time is it? That sort of matches this last format right here. What blank is it? So in order to send this question via the protocol, how would I do that? Well, I think I do it IST space time. That's sort of how I encode that question for the computer to understand it. So let me try that here. So I'm going to connect to the server. And I'm going to try IST time, and then hit enter. I get back to the time is this thing. So I'd love if everyone could give that a shot on their own. Just connect to the server, issue a request, IST time, give back the answer. The time is this thing.
Does IST have to be capital? And also when I press the left arrow, it gives me bracket D caret.
Yeah. So you get something like that.
Yeah. What's that?
Yeah. So the way that Netcat works, you can't actually arrow key around. If you want to go back, you got to hit backspace. The reason why it gives you that is there's sort of some things built into a terminal that result in the arrow key having that behavior when it's not handled specifically by the application. And Netcat doesn't handle that particular sequence, that particular operation. So just you got to backspace your way through. And around if they have to be capitalized, the way this protocol is laid out, yes, they do. So that's another key thing here where being detail oriented is going to be really important pretty much for the whole of the section, but I'd say generally as a software engineer, but especially for this section of careers in code. If you like did something like, for example, missed a space or made things lowercase, they're not following the protocol as it is outlined. And it might work, but that's kind of like undefined behavior. Usually you want to try to keep things as close to the specification as you can. But let's see, I'm actually not sure if it'll work. I have a feeling it probably will. No, it won't. Yeah, so it looks like it'll only work if they're uppercase. But here's an example of one of those error responses, by the way.
Okay, thank you. I have the time as well.
Excellent.
Showed the sample from his son, whose mother was Karen Contaminant. The father and son both share the upper band.
Looks like, Rain, I think you have maybe some background noise.
Oh, I'm not on mute. Sorry. Hold on.
No problem at all. Cool. How are folks doing with this? Can I get some thumbs up in Slack if things are going well? And if not, let me know. Let's figure it out. Cool. Lots of thumbs up. Genevieve asked, does this only have questions? Does this only have answers to questions you have loaded? Yes, it does. So this can't just handle arbitrary questions. I've sort of got a bunch of prompts that it's sort of picking from. And if you were to, I mean, you can try it. Try asking it a question for just something arbitrary and see what happens.
It gives you an error. Says
Yeah.
cannot answer that particular question.
Yeah, it's a good one. ST day. Oh, that one works. How about that? Yeah, I mean, I had fun and I built out some stuff I maybe didn't have in the examples, or maybe I do, I forget. But like favorite, I don't know, ice cream. That's not going to work. So yeah, it's kind of limited in what it supports. Cool. So actually, before we go to the next one, I'm curious if anyone is wondering what's up with this format for this time. Is it something that anyone is curious about, or did everyone just kind of gloss over it?
No, I'm curious because it's saying what 11:53. So right 11:53, I believe. So where's the server based out of?
Yeah. Okay, well, it sounds like that you've got a hint a little bit as to what's going on. So the server is in UTC time. So generally, gosh, I don't know if I wanted to go on a whole time rant right now, but I think I'm gearing myself up for that. So time is a complicated thing in software. Time, like figuring out what time is it, the whole system of time has been optimized by humans for like thousands of years is a thing that makes a lot of sense to humans. This idea that this time, like this relative notion where like when the sun's directly above you, it's noon, like ish. I mean, it's not exactly like that, but generally that was kind of the idea. So what that means importantly is like it's different times in different places in the world, as everyone's aware. There are these things called time zones that developed. And what ended up happening is like through history, as the world's become more and more connected, this notion that like it used to be that you never really communicated, like everyone you would talk to sort of like hundreds of years ago would all be in the same time zone because there wasn't really a way to communicate long enough distances where that mattered. Like it was, and like you were all proximate enough to each other where like you didn't really even have to think about time zones. But now we live in this world where you can send a message to someone across the world in like, I don't know, like tenths of a second or less. And this becomes critical. Like you need sort of a way where time can be universal across everything. And yeah, Rain kind of pointed it out in chat, but we have this thing called UTC. It's roughly equivalent to the time in the UK, I think. I forget if the UK has daylight savings or not, but it's like the time with a zero offset, zero daylight savings or hour offset. So, and Rain also asked, so does this mean the computers always start at, I think you meant the 0 point?
I did. I did.
And yeah, so like you're starting to kind of hit on some things here where you need a way with computers where you can have like a time that has some consistent properties. So ideally you want to have like a time that like is all the same everywhere. So yeah, generally like UTC is the time at the the 0 time zone offset on the meridian that goes through the UK. That was sort of the decision made. We're going to standardize on UTC time. But the other reason why UTC is, well, one of the other reasons why UTC is critical is because UTC does not have daylight savings. And if you want to get a software engineer angry, ask them to solve some like weird time bug that involves daylight savings. And like they will be like an move beginning of the day. And as the day goes on, they will get into more of a grumpy. The reason why I say that is like daylight savings introduces all this extra complexity. There's this great blog post that I often like to recommend that people read. I'll dig it up and post it in Slack, but it's called like something like 10 things you thought were true about time that aren't. And what it is, it's like things where like, for example, people are like, time, it always moves forward. Nope, time doesn't always move forward. You're like, wait, what? How does time not always move forward? Well, yeah, time as you observe it always moves forward. But like the wall clock time you're looking at, like on a clock, no, that doesn't always move forward. Daylight savings, like the time jumps forward and jumps backwards at certain points. And like that means that across the daylight savings boundary, like the time from like length in duration from one point to like the next day, like with the daylight savings jump, it could gain an hour, you could lose an hour, like, and that becomes a real problem when you need a computer that's like just has like a constant notion of time that like can always compare against. Anyway, I didn't mean to get quite as involved in this as I am. I'm a little bit passionate about the topic of time, and I think many software engineers are. But this is all to say that computers generally you're going to work with are all in UTC. UTC has some properties that work really well for time across the world. It's much simpler to work in a UTC only system than a system that is in many different time zones. So generally that is the way things work. Computers, for the most part, will always be in UTC. And if you're viewing a local time, like a wall clock time, I keep using that term, but think of it as like your local time, like the time where you are given your location. That is often just converted from UTC. Like there's a UTC version behind the scenes is just like, that's the point of truth. So anyway, that's why what you're seeing there is like 11:52-ish. Because, and actually now we just passed 8. I bet if I did IST time again, yeah, it's tomorrow. So we just went across a day boundary in UTC because the sun, that's where like, that's how the time and the world and all that. Wow, that was quite disjointed. But yeah, so that's why. And the way you can tell this is in UTC, besides just like looking at it and kind of analyzing it. So this is like the 24-hour representation, hour, minute, second, millisecond. Is the Z at the end? Whenever you see a time that ends in Z, it means UTC. Yeah, Corin just said time is such a weird construct. 100%. You know, the only thing that I think could have made time even worse is if someone had come up with like a metric and a US imperial time. That is the one thing. There is a standard time across the world, the one saving factor. So I don't know. It's a whole thing. I'll dig up that blog post. It's really quite a good read, I think. So, okay, time rant complete. Let's move on to the next question. How many CPUs do you have? Give this one a shot. I'll give you a couple minutes and then we'll go through it together and you can ask me questions.
All right, I can tell you the percentage of CPUs, but not the exact amount quite yet. Yeah, wait, yeah.
Just posted that time link in the channel if folks are curious. Okay, cool. I heard, I didn't hear who, but someone mentioned percentage of CPU cores.
Yeah, I did. I probably went to the wrong place. I went into the activity monitor.
Ah, so
Yeah.
I am saying ask the server, make a request to server, ask it how many CPUs you have using the protocol here outlined. So
Of
with
course
netcache.
you're asking that. My bad.
No problem. I did see that Ozma, you said 1 CPU cores. I think that's right. Yeah, I maybe should have clarified that. This is a question you're asking asking the server. This isn't a thing you're looking up on your own laptop. So you're using the question decoder here. You're figuring that out and sending that with netcat to the server. I'm seeing a decent number of folks in the chat though who got it right. Yeah, I believe it's 1. Let's go through this here. So I don't think I got the pluralization right, but whatever. So how many CPUs do you have? So MAN is how that decodes how many blanks do you have. So I'm going to type MAN CPUs. I have 1 CPU cores. Yeah, I think I used to have this running on something that was dual core and then downgraded it and didn't update that. Didn't update the pluralization on that, but yeah. Cool. So that's sort of roughly how that works. Let's move on to the next one, but feel free to keep on rolling along here. So what is your favorite operating system?
Mac OS.
You got to ask the server the question. I'm not asking you, although I'm curious to know, but so I'm seeing a lot of answers in the chat. Linux. Hey, I'm seeing a decent number of folks who posted Linux. Cool. So let's go through this here. So what is your favorite operating system? So I'm going to kind of decode this here. Imagine probably folks are starting to get a hang of how this is going, but what is your favorite blank? So it decodes with FAV. So FAV operating system Linux. There we go.
I asked it what my favorite color was, and it said orange. So that means that that's your favorite color, since that's what's programmed in there.
Oh, fave color. I mean, I don't know if it's my favorite color. I don't know if I have a favorite color. I haven't spent much time thinking about that. But the server's favorite color is orange. I don't know why I picked that, but I guess it's what I picked. I didn't answer your question at all, but there it is. So we got 2 more to go through here. I mean, it's all kind of different variations of the same. And I'd imagine if you sort of gotten the last few, these other ones are not going to be too difficult. So I'll leave this up here, but feel free to work on this. I do want to ask though, for folks who have not had success or having some bit of difficulty, please let me know. Like, is there anything that anything you're running into, any errors, any way I can help?
I just wanted to say what I noticed was how sensitive like it is So when I was doing the fave, I was doing just capitalizing the F, and then that's why I was getting the error. So I
Mm.
tried a few other ways just to see what would happen.
Yeah. So the casing and the syntax and exactly how you type it out, it's a lot like JavaScript in that way, where if you don't get it exactly right character for character, it's not going to work. You folks are really just like exploring all my like tree of questions here. Yeah, you're a lot more creative with these questions. Cool. Well, let's quickly go through this one here. Match at this point. Oh, actually, yeah, I guess I should also say if you just send it an empty thing, it's just going to be like, I can't do that. Empty is not valid. So another nice little edge case there. What is your favorite flower? So in this case, it decodes with FAV, just like the last one. So FAV flower, violet. Cool. And yeah, someone already got the car. So I guess you kind of already figured that out. But same kind of thing. What is your favorite car? Decodes with FAV, FAV car, Volvo. So that's kind of where it is. So that's all I had for today. We've got a nice riveting program tomorrow, but I guess would love to leave it open for any other questions folks have, or yeah, I guess I don't have anything else on the agenda here. Also, like, I'm quite well versed in everything else that's been taught so far. So if you have any questions about things from like previously in JavaScript or before that in Careers in Code that maybe you want a different explanation than what Max gave, I can try my hand at that as well. Oh, Taylor asked, will we be able to access this to practice after class? Yes. So this server will stay up. We're going to be using it throughout this whole section. A lot of things are going to be on Careers in Code.xyz. It will be up for at least the next 3 months. I just prepaid for the cloud hosting credit, so it's good to go. So yeah, you'll be able to access this after class. You can make it, send any questions, get back answers. And this presentation is available, so you can go through all these if you want. So Shay asked, will there be more questions and answers to this server? So tomorrow we're going to be using a different protocol. We're still going to be sending questions and answers, but we're going to be doing it in a real protocol, not the sort of contrived one I made up. The real protocol is called HTTP, and you're going to be getting very familiar with it over the next 2 weeks. So yes, but not with like this protocol. And Gagan, you asked, what is your favorite programming language? I'm going to give you a not straightforward answer, and I'm going to say that I don't know if I have a favorite, but I think for certain types of problems, I have preferred languages to solve those kinds of problems. So if I'm like building a web application, I'm probably going to be writing some JavaScript. If I'm doing some sort of like complicated compute thing that requires like a lot of number crunching, something like C or Rust could be a good option. Or then like if I need to write some backend server software, like JavaScript could work, Python could work. One that I've used a lot that I like probably more than others in some cases is this thing called Elixir that I've used at a previous job. So I don't know if I can like give you one answer because frankly, like many languages are just not good for certain tasks. Like there are domain specific tools, since maybe some have larger domains than others, but at the end of the day, like using one hammer to hit every nail is often not the best solution. So and I saw someone else. Oh, Palash, you had your hand raised. Yes.
Right. So what is the if let me know if I'm getting ahead of myself, but what does the back end of this look like? Is it like a bunch of if statements, or is it like an API that you called? And will we be learning?
Yeah. So you will be learning about how to build these, not in this module and on this section. That's in a few sections. But in effect, think about if you wrote a program in something like Node, and that program could run like an nc-l command. And then every time that it received a message, it would run like a function with the thing you typed in. And then that function could have the opportunity to like send data back. So in effect, that's what I've done. There's sort of a version of nc-l, like a way in Node you can do that. That's built into Node. It's called the I think net package. I forget. But it's built in, and you can. It's like pretty low level. So what I have is I've got a function that just receives what you type. Does like I think it like splits it by space. Looks at like the first thing you type and do a big like mapping of like options to like the answers, and then just gives you back that answer. So I can send you the code if you're curious and want to dig more into it.
Yes, please.
Cool.
Does your server time out? It looks like I just got disconnected.
Yes, but the timeout time should be pretty generous. So well, it should be. It might not be. I will be honest that this code I wrote for a previous cohort and sort of got it working and didn't go through the rigmarole of all the tests. So I might have misconfigured the timeouts or something, but it should like be pretty generous.
And is it based on time from your last question or time from when you logged on?
That is a good question. I think it is time from last question. So what I will say is I definitely know that HTTP tomorrow it's configured correctly, because that's something students run into quite a bit. And I think, Doug, you probably remember typing those up by hand, the tediousness of it. And so I know for tomorrow it's configured right. I just don't know for today if it is. Actually, on that note, I'll also mention, you probably saw me do it here, but when you hit enter, you can run multiple commands in a row. That's fine. Or you can write one like fav flower enter and then control C. Like you can do it either way. There's really no, at the point we're at now, there's really no benefit of one over the other. But just like both are valid options. Cool. I'm going to go grab that code just so I don't forget about it here, and post that in the channel so folks can take a look at it if they want. Hack upstate. I think it was in here. Yeah, if I can't find it quickly, I'll just dig for it later. But yeah, here we go. Maybe not.
So what language is it written in?
It's JavaScript. Oh yeah, here we go. Here we go. Yeah, I wrote it a long time ago. I just haven't moved the code around. I think it is this. Also, this code is quite messy. So please don't judge me too much. But here we go. So I'll post this in Slack. You can take a peek if you want. You sort of have the whole mapping of all the questions and answers in here too. So if you want to kind of like exercise different paths and try things out, you're welcome to do it. But everything else in here we're going to be using for the rest of the day, the rest of the module. So that's what all it's about. It's just sort of everything in just one big file because I just needed to get something out there, and that was easiest. Cool. Okay, so the server code. Sweet. Any other questions? I think if not, we're probably done for the day.
Thank you, Ryan.
For sure. Have a good evening, folks. See you tomorrow.
Good night, all.
Bye.